Hi and welcome to this short video in the MRDCL Fundamentals series in which we look at outputting or repunching data to a different layout. Now this is occasionally needed when you want to supply data to a client who actually wants the data laid out in a particular format. Now there's various ways of doing this, but I'm going to show you the technique I think that works best for most cases. So I've got a control stage here. The first thing you might notice is that I've got this syntax here that says C equals less than greater than. That's a way of getting MRDCL to prompt you for the file name that you want to read in. And then I've got P equals less than greater than, and that's a prompt that will come up asking you what you want to output your data file as when you've recoded it. Now the next thing you'll notice is the data record I've got here is actually only 100 characters in length. In fact, it's considerably less, but I'm just going to use the first 100 characters for my data file. So I've set it to twice that length. I've said the card characters is 200, but I'm only actually reading in 100 characters. Now what I'm planning to do here is I'm going to use the first 100 characters to read the original data, and then I'm going to use the second 100, 101 to 200, to output the data. So what I'm doing here, I'm going to first of all say that I want to put in 101 to 103 what's in 1 to 3 in the original data. So that's just really literally moving the serial number, the first three columns, into the same columns but in 101 to 103. Then in the next statement I'm going to move columns 5 and 6 into 104 to 105. So I'm effectively moving them one to the left. And then I'm going to define a variable called gender, which I'm going to pick up codes 1 and 2. And this shows you that you can actually also output not just data from columns from one location to another. You can just put a variable in there as well, and it'll move gender from variable gender into location 106. Now if I punch out 101 to 106, that's where my new data layout will be stored, and it'll output that 101 to 106, perhaps confusingly, in 1 to 6 in the new data file. So even though it's currently storing it in 101 to 106, it's only punching out those 6 columns, and therefore they'll end up in the first 6 columns in the new data file. So let's quickly run that and see what happens. So we click go. As I said, it's going to prompt me for the data file. So there's my data file. Ask me if I want another data file. I don't. And I'm going to output my data to output ASCII. And it should have run that now. So we can look at the original data file. So here's the original data file, and we can look at the new data file and see what we've got. So there's my gender, which I think before was right down the record down here in those fields there. So that's moved the gender into my new location here. And these were the 2 columns that were in 5 and 6 that I've now moved to 4 and 5. There they are. They've moved one along from here. Those 1 and 1 there were in the 5th and 6th fields, and I've successfully moved them into the 4th and 5th fields. So these tools allow you to recode data. The other tool that you've got is that you have a make statement that allows you to make things on columns. So let's have a look at that. So, for example, if you had perhaps a more complex variable, this would be more appropriate. I'm going to use the example of gender here, but it might be something that's quite a complex definition. You might want to say something like this. You might want to say that if gender is a 1, or more likely a more complex variable than that, you want to make 107 a 1, blank and 1, and if it's 2, you want to make it blank and 2. You would change that to 7. Now, to use a make statement, you have to use the card characters binary command rather than the card characters command. That's just a tool that doesn't work without having binary in the card character statement. Otherwise, it will make no difference to your run. So we can do that, and I've just changed the punch statement to punch out 7. So let's run that and see what we've got now. Let's compile and execute. Pick the data.asc again. No further data file, overwrite the output ASCII file, and let's run it. Now you will see a slight difference in the output this time. What we're going to get now is it looks pretty much the same, except you would expect it perhaps that the two formats for gender, that where we picked up codes 1 and 2 and just moved the column, and where we physically chose 1 and 2 would be the same, but that's not the case. When you go for card characters binary, it assumes the code order goes VX0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and a V is represented by an ampersand and X as a dash. So consequently, for the first definition of gender, we've got a V and an X coming out, or an ampersand and a minus for this definition on 106. But for the second one, we've actually picked the code 1, which is absolutely fine. So one way around that would be if you've wanted to use the card characters binary and make statements, you could, if you wanted to do something like this, you could replace that definition on 106. We could convert gender to igender here, so it now becomes an integer. That's a perfectly good piece of code. And now we could say define 106 is igender. Now you might think that works, but MRDCL is a little bit fussy here. Because it's a number going into a field, you have to repeat the column number and say define 106 to 106, so it treats it like a numeric as igender. So that's a little bit confusing and makes things a little bit more difficult, but we can now run that, and all being well, if we overwrite the output file now, open up output.asc, and now you can see we've got 1 and 2 for both fields, which is what we have hoped for. So that completes this short video on punching data using MRDCL. Thank you.